This lecture is a demonstration of linear regression, part one. My name is Alden Gross. I'm faculty at the Johns Hopkins Bloomberg School of Public Health. So in this example, in this demonstration, we will be examining predictors and correlates of cognitive performance in the U.S. Health and Retirement Study, HRS. This is a study in the sample size I'm using here is 6,825 participants. We'll be looking at 7 different variables. Our primary outcome variable is called UTOTCOG. It's a total cognition summary score. In 2014, age is the age of the participant. Female is female sex, 1 for female, 0 for male. Degree is one's highest degree of education. Hispanic indicates Hispanic ethnicity. Race indicates race. I believe that it's coded as either white or black. And school years is the number of years in school for a participant. So the first thing we would do is explore our cognitive outcome. I'm showing an exploration here by first generating a histogram of the score, where you can see it's a somewhat normally distributed continuous score that ranges from about 0 to, it looks like, 32. And I'm also summing the variable, and I can see that there are 6,824 observations in the data set that have the cognitive score. And indeed, this does confirm that the variable has a range from 0 to 32 points. I provide, on all of these slides, I'm providing Stata syntax, usually in the on the left-hand side. Here we conduct a simple linear regression of the UTOTCOG, the cognitive score on age, and I'm graphing the relationship between these, so that we see a graphical relationship between cognition and age. First, let's look at the graph. The y-axis shows the cognition variable, which ranges from 0 to 32. And the x-axis is age. And the line here is a straight fitted line. It's the regression fitted line. And there's some slight decline, a negative tilt here. But it looks like the... so there's some decline. When we look down at the regression output, I want to zero in on the beta-1 coefficient, the beta coefficient for age, which is negative 0.185. So in other words, this means that there is a 0.185 drop in cognitive scores per 1 year older age in this cross-sectional sample. This parameter, 0.185, has a standard error of 0.012, and the coefficient divided by the standard error equals the t-statistic, which can be translated into a p-value, which is highly statistically significant. We can also get a 95% confidence interval for this beta coefficient here, which is shown, excuse me, on the right-hand side of the regression output. Looking up top in the regression output, we do see, as we saw earlier, that there are 6,824 observations in this sample. The F statistic is highly statistically significant. The F statistic is chi-square distributed, and it is basically telling us that the combination of covariates, in this case just age, is highly related to the outcome of interest. The R squared shows describes the proportion of variance in the outcome explained by all of the covariates. In this case, we can see that 0.03 or 3% of the variability in cognitive performance in this sample is explained by age, which is not high. What else should we say? You know, in terms of, so the R squared is not high, but that might be okay, because as I mentioned at the beginning of this demonstration, the purpose here is to examine predictors and correlates of cognitive performance in the health and retirement study. I'm not interested in predicting cognitive functioning. If I were interested in predicting or explaining lots of variation in the cognitive functioning outcome, I would want to maximize my R squared value. But as stated, my question states that I am interested in exploring correlates of cognitive functioning. So age, as we can see, is definitely statistically associated with cognitive functioning. It's just that age, even though it's statistically associated with older age is associated with a lower cognitive functioning, it's just that age by itself does not explain a great deal of the variance in the cognitive functioning outcome. So that is an important distinction to make. This is called a simple linear regression because we have one outcome and just one predictor or adjustment variable. We can also run a multiple linear regression. Here I'm regressing the cognitive score on age, as well as female, degree, Hispanic, race, and school years. And in this regression, we have a slightly smaller sample, primarily because there is some missing data, I believe, in some of the education variables. But we've gone from a sample of 6,824 to 6,807. This merits exploration to better understand where our sample, why we have a reduced sample in our regression. The F statistic is much more strongly significant, which implies that all of these variables, these 5 additional variables, in addition to age, are contributing a lot more to being associated with the cognitive outcome. The R squared now is about 25%, which means that, again, 25% of the variation in UTOCOG is explained by these demographic variables. The age coefficient is attenuated, but the interpretation is the same, is almost the same, except we would say now that there is that a 1 unit difference in age, 1 unit older age, is associated with a 0.15 unit lower cognitive score, adjusting for all of these other variables. You could say adjusting for, or controlling for, or conditioning on. These things all mean the same thing. These words all mean the same thing. Looking at these other predictors, we can say that, for example, there is a 0.637 difference in mean, on average, in mean cognitive score between females and males. It looks like females have a higher score than males. And excuse me, I will not interpret all of these other coefficients. I will note that in terms of statistical significance, all but one of these predictors are statistically significantly associated with cognitive score. An exception is Hispanic ethnicity. Even though the beta coefficient is -0.19, the standard error is quite large, and the coefficient divided by the standard error leads to a t-statistic of -1.09, which is associated with a p-value of 0.277. This is not statistically significant, and the confidence interval here overlaps 0. This ends part one of the demonstration of linear regression.